tongue cancer. Now, regarding the treatment, what we have now, we have surgery that as one of the treatment, the number one therapy, radiotherapy, chemotherapy, and lately, quite about 10 years ago until now, there's a new technology coming out: immunotherapy, hormone therapy, target therapy, chemoprevention, and nanomedicine. But is it really works? That's a big question. Okay, is it a successful cancer treatment? And how about the cancer death? Is it reduce the worldwide? Do we really satisfied, especially the late stage of cancer or metastasis to the liver or brain? And how about the quality of our patients and the cost of the treatment? So do we need an innovative strategy? That's very important. So therefore, we want to change our mindset, we want to change our strategy. Rather than we go to a normal way, we should do more innovative strategy. Here, a good example as what the data in United States from 1950 2001 is about 40 years, where you can see very clearly there's not much difference in terms of death due to cancer for 40 years is in United States compared to other disease. Heart disease, a lot of percentage been go down, and in other disease, pneumonia and everything, it low very good. The treatment is really works, but not for cancer. So do we have to change this strategy? Can we change our lifestyle? It's very difficult. Can we change our food supplement? Also, it's very costly and also very difficult. So in my opinion here, we might change our cosmetic product in much more better way. It's more in healthy kind of condition of product. So here I will suggest that we should use our plants as a new product in our cosmetic, for our cosmetic consumer. Now in Malaysia, we have more than 8,000 plants species, and 10% of it be reported as a medical value. And and Malaysia is very well known for biodiversity and a lot of plants that we can use for disease, to treat disease, especially cancer. And there's many study been done for in vitro preclinical study as well in Vivo, but not much in human clinical trial yet. Now I will introduce one plant here where I work since year 2009. It's almost 10 years I work on this plant, where we known as Streblus asper. It can be found in northern Malaysia, in Thailand, India. So where this plant is well established, where we can found easily, but not in South Malaysia. So what this plant can do, it be known as a toothbrush tree in Thailand. In 2000, start from 2009, I work on it as I published a few papers on it to show the potential of chemopreventive activity against osteosarcoma. And now I work on cervical cancer, on prostate cancer, on tongue cancer, in vitro and Vivo model, where I'm going to share it with you. Here is some results on osteosarcoma, tongue carcinoma, and cervical cancer in vitro result. On the top there you can see the untreated cells, where it shows clearly the growth of cancer cell, and when you expose it to Streblus asper extract, it shows the shrinkage, the apoptotic condition occur very clearly. Okay, here we can show you the shrinkage of the cell through our microscope analysis. It's very clear, the plant extract shrinkage the cells. Now when we expose it to the cell line, we get the dose IC50 according to type of the extract. Okay, so it have various of dose according to the susceptibility to the cells. As osteosarcoma, maybe the 0.5 milligram. For tongue carcinoma, maybe 1.1 milligram per ml. and for other cells like cervical cancer, 2.5 microgram per mil. And here is the anti-proliferative activity, as clearly it shows that this drugs, this plant extract showing anti-cancer properties, where it inhibits the cell growth up to 8 days. And this is the apoptosis results, show that the early apoptosis induced 2 times higher. The same patterns go to the cervical cancer cells. The early apoptosis go 6 times higher compared to the untreated cells. And when you see the pattern of the cell cycle arrest, where the G2M level being induced clearly in the exposed to the asper's root extracts. And as you can see in the cell cycle analysis, again with the cervical cancer, just now you see is the tongue cancer, now is a cervical cancer, also with the same pattern where the G2M phase been induced, double up. And we try to study on osteosarcoma which are the proteins that been modified or been low expressed or highly expressed. So we can see the cleave caspase 9 is been, and with the cleave caspase 3 been induced, where the MAP kinase and BCL2 been down regulated. And for cervical cancer, also we found similar results, and especially with the NF-kappa B being induced and also down-regulated in the P38. For cyclin D1, also some of the cyclin been suppressed. And here we show how this is just our suggestion in signaling pathway, where are the proteins be involved with this plant. Here in just now with the osteosarcoma, here in the with the HeLa cell cervical cancer. And this is for the cell invention, for inhibition of the cell invasion, how the pathway look like through the TMP pathway. And we also want to clear up with the toxicity condition, whether it's safe or not. So therefore we use a normal kidney cells and normal liver cells. On the blue color there, showing that the cell viability is very good, 100%, there's no inhibition, where the control showing the red color there is a negative, is a control that where the cell been killed. Okay, so our extract is very safe. This is the morphology look like, where the treatment with the root extract showing no modification of phenotype of the cells. And the heavy metal analysis also show very safe level, where is much more low number from the Malaysian Poison Act, plumbum, mercury, cadmium and arsenic are in the good condition. We also run genotoxicity analysis, where it's a negative, there's no modification on the DNA. So at this level for this product, it shows very safe, and also the effectiveness is worked on. Okay, it's kill the cancer cell, it inhibit the cell proliferation activity through caspase and MAP kinase pathway. And therefore we publish in books, and we patented these results as a plant-based cancer chemopreventive agent. And we try to change the extract into a cosmetic product. We change to mouthwash product, a gargle, and also we also formulate for ladies hygiene product for the ladies. It works, and we try to commercialize it. We put in our competition, we got a few results, and it been also been getting to a news and in a TV program. And then we start to work on animal study with the same plant. We work for cervical cancer. We do a xenograft model as shown in the slide. and the result is very promising. We do this for 21 weeks of giving the extract to the mice, and it shows very clearly the shrinkage of the tissue.